Welcome students. In this video series, we are seeing data structure. Now we will be seeing circular linked list. Now what is circular linked list? Now you are aware about linked list where you have nodes. So I have drawn a diagram here to show you the linked list. Now this is a single linked list, but in this topic we are going to see is program on circular linked list. So what is circular linked list? Circular linked list is nothing but a linked list in which the last node, instead of null, it stores the address of first node. That means here it is pointing to the first node. If I draw a link from last node to the first node again, then this type of linked list is called as a circular linked list. Now what are the advantages of circular linked list? Now you imagine you have a single linked list of 1000 nodes and you are at node number 997, and from that node number 997 you have to reach to node number 15, right? What you will do? So there is a facility in circular linked list to go to the next 2 3 nodes. From 997 you go to 998, 999 and 1000, and you can come back from 1000, that is last node, to the first node. So this is one of the advantages of circular linked list. So if this is one of the advantages of the circular linked list and it looks like a single linked list only, then what will be the difference in program of single linked list and of circular linked list? This is a valid question. Now the answer to this question is there is no difference in C program for single linked list and circular linked list apart from the deletion of last node and insertion at the end. Now why I am saying that there is only difference between insertion in the end and deletion of the last node. Also there will be a difference between insertion in the first node, because whenever you will insert a new node here, at that time if this is your first node, then start will be pointing to this first node, and this link you have to break from the last node and you have to establish like this. So such minor changes are there in between single linked list and circular linked list. So it is very easy to understand this program if we have watched our previous video on perform operations on single linked list. Okay, we will continue now. Now here there are header files stdlib.h for malloc function, stdio.h for printf scanf function, and conio.h for clr function. Now there are function prototypes declared. These function prototypes are create, display, insert in the beginning, insert in the end, insert in between or after a specified position. For that I have given name as insert underscore pos. Then delete beginning. This will delete the node from the beginning. Delete in the end. This will delete the node from the end. And delete position. This function will be called if you want to delete a specific node. So these are different functions given to you, and then there we have declared a structure. That structure is same as in single linked list, because structure will define how your node will look like in single linked list or in double linked list, or in circular linked list. The node will be same, having two part. One part is data part and another part is link part to the next node, hence the name given as next. This will link to the next node. So the structure remains same, struct node int data, struct node pointer next. After that I have declared some global variables. Two global variables I have declared, that is, one is start pointer, this will always point to the first node, and another is last pointer, this will always point to the last node. After that main function begins. So let us see what is there in the main function. As you can see, the main function looks similar to single linked list, where we have one variable choice. This will read your choice. Now different choices are given to the user. Those choices are 1 for create, 2 for display, insert in the beginning, insert in the end, insert after specified position, delete from the beginning, and likewise. So all these choices are given to the user, So among from these choices, one of the choice the user will choose, and then what will happen? Then this switch will come in picture. Now this switch, what it will do? Now this switch will call the appropriate function according to the choice of the user. Now you are aware one is the choice of the user when the user want to create, 2 for display, 3 for insert beginning. This is very easy to understand. So appropriately the function will call, and after that this case will break, and after the break of case this switch will end, and after the end of the switch the while loop will continue. That means the while loop again display the options. So if you want to end the program, you have to choose the option number 9 to exit from the program. Otherwise the program will be in a infinite loop. If at all if you use the wrong choice, then it will print a message calling wrong choice. So this is very easy to understand. So let us observe one by one these different 8 functions. The first function is create function. What it will do? It will create a node and it will store the data in it, and it will also analyze whether that newly created node is the first node in your linked list. If it is the first node in your linked list, then it will make start to point to the newly created node. For that I have instructions like pointer declaration, then allocation of memory using malloc, then checking whether memory is allocated or not. This will never happen in modern computers, because in modern computers there is enough memory space available, but still for a programmer's point of view we have to check for this condition also. Then after that I have asked the user to enter the data, and the entered data I have stored in the node, and the next point of the node I have make it as a null. Then what happens? Then I am checking whether your this newly created node is the new node or it is the first node in your linked list. To that I have to check if start equals to null. If this is true, that means the newly created node is the first node in your linked list, and you are aware that to the first node always start pointer points. Now what happens? There is one more pointer called as last pointer. Now for last pointer, what you have to do? Last pointer will also point to the this newly created node, because there is only one node existing in this node. And now it is a circular linked list, and you are aware that in circular linked list the last node is pointing to the first node. Now in this case what happens? This is the first node created, so start is pointing to this node and also last is pointing to this node. Hence it will the next pointer of this node, instead of null, it will be pointing to itself. So this is the only difference between single linked list and circular linked list. If this is not the case, then what should happen? If the newly created node is not the first node in your linked list, that means already there exist some nodes in your linked list. For example, I will take there are total 2 nodes in your linked list. So earlier your linked list was like this, and just now you have created a new node. So the diagram will change to this. So that the diagram will change to like this, because the last node, earlier this was the last node, its next pointer will point to this temporary node which is a newly created node, and last will shift its position. So last will point to this newly created node, and last of next will point to the first node, because this is a circular linked list. This will happen if the newly created node is not the first node in your linked list. If the newly created node is the first node, then we have discussed this few seconds earlier. Now we will see the display function. In display function, we have to check for the condition if your linked list is empty or not. If your linked list is empty, then we have to just print the message. Otherwise, what we have to do is we have to take a temporary pointer ptr which will point to the start node, and while ptr of next is not equal to last of next, up to that you have to go on continue and just print the data, and you have to just shift the pointer ptr to the next node by writing the statement ptr is equal to ptr of next, and after that one node will remain. For that you have to write one more printf to print the data of last node. Now we will see how to insert a node in the beginning. To insert a node in the beginning, you have to take a temporary pointer and you have to allocate memory to which this temporary pointer will point, and after that you have to check whether the memory is allocated or not. Then you have to store the data. This much is very easy. Then insert in the beginning, you have to check whether your beginning node is whether your linked list is empty or not by checking the condition if start is equal to null. This means the newly created node is the first node. This we have already discussed. If this is not the case, then what should be happening? Then else will execute. This else what it will do? It will make temp of next equal to start, because this is a insert in the beginning. So hence newly created nodes next part will point to the first node, and then first node's start pointer will change its position, and then last node's next part will also change its position. That's it. Then after that there is a function called as insert end. Now this function what it does, it will insert a newly created node in the end of the linked list. For this also we have to create a temporary pointer which will point to the newly created node. We will store the data, and after that what we will do, we will check whether your linked list is empty or not. Then what we will do, we will just make the arrangement of the pointers properly. That is, last of next will point to newly node because we are inserting in the last node, and last will change its position, and after that last of next will point to the start pointer. Then if you want to insert in newly created node in between somewhere, then this logic will remain same as we have discussed in the single linked list. Then delete beginning. For delete beginning, what we have to check, we have to just reshuffle the pointers. Like for example, ptr is a newly created pointer, is a temporary pointer which will point to the first node, right? By writing ptr is equal to start. After that what we will do, we will make it like start is equal to start of next. Due to this line what will happen, your start will shift. Once your start is shifted, you have to what you have to do, you have to make arrangement for last of next. Once your start is shifted, then last of next will also shift. Then you can free the pointer, or earlier you can free the pointer then change the last pointer, it will also work. Then we will see void delete underscore end. Now we are deleting the last node. What we have to do, we have to just reach up to the last node. How to reach up to the last node? We already have a pointer last which is pointing to the last node. But what happens here is, we are deleting the last node, right? So we will take a pointer ptr which will point to the first node, and while ptr of next is not equal to last, up to that this while loop will continue, and at one point the ptr pointer will pointing to the one node before the last node, right? Now ptr pointer is pointing one node before the last node. That means I can safely delete the last node, and you can reshuffle the last pointer as temp pointer, right? ठीक है? Okay. And then you have to make the last of next as start, and delete after a specified node. This logic is same as single linked list. ठीक है? In next video we will see last program, and then all your practicals are covered.